Hi there. So here's the lesson we did today, but it's going to be my version, so it might go a little bit quicker, but it's a video version, so you can go back and refer to it and rewind if you want to. So we talked about connecting English with mathematics and graphing lines. Our first activity or investigation was to write a sentence that could be represented by the equation 4x plus 6 equals 22. We talked about using different words in place of like the pluses and the equals. So the plus sign could be plus or add. Equals could be is or just equals. And then we also talked about how x represents something or it's a variable. So it is some number or some value or some number. It's up to you how you want to do it. So then when we write the sentence, 4x is 4 times x. So we would say 4 times some number or some value plus 6 is 22. So we have a nice little English sentence that also is representative of our mathematical equation that we have. Then we looked at another example. Write a sentence that could be represented by the equation half x plus 1. So again, half x is like 1/2 times, but another word for multiplication could be of. So in this case, and again, x is some number or some value. So in this case, I might write this 1/2 of some number or some value plus 1. Okay, again, this is our English sentence that represents our mathematical equation. Okay, so then we looked at different words that we could connect with math that might mean addition, subtraction, multiplication, and division. So some of the words we came up for addition was like plus, more, addition. If something's increasing, it means we're adding to it. If they ask you for the total or they actually tell you to add, those words all mean addition. Subtraction, we looked at the word subtract, minus, if they ask you for what's left over, take away, something that's decreasing means you're subtracting it, or what is the difference between. So if you're trying to find the difference between numbers, that would suggest subtraction. Some words for multiplication, I asked you to come up with some of your own, but some of the ones that you could use are product, of, per. The words twice and double implies that you're going to multiply it by 2, so that I've included those. In all or each, those words all mean multiplication. And then there are some division words that I kind of wanted you to look at or take note of. Words like divide, quotient. Seems kind of fancy, but it means to divide. If we're splitting things up or separating them, they would mean division. Equal groups means splitting it up into equal groups. The word half is actually division. It means you're dividing something by 2. So those are all words that might mean division. Okay, then we looked at an example, and I said, write the following phrase as a mathematical expression. The value of 5 increased by a number. So I talked about how we could split up each of the sentences and kind of pick out what we need. So the value of 5, which would mean 5, increased, if we go back to our words, implies that we're adding by a number. And by a number could be any number. And we saw before that that could be x. So in this example, we might write it 5 plus x. 5 increased by x. Part B. Write the following sentence as a mathematical equation. Half of a value decreased by 7 is 1. So I talked about a value, same as like by a number. So that would be x. Decreased, we talked about, that would be minus by 7. Half, 1/2. This of here implies that we're multiplying. And then is 1. So we can, as long as we're looking at every single little thing, we can easily come up with our equation. This is 1/2 times x minus 7, and it equals 1. Very last one. Translate the following sentence into an equation using two variables. Mario's daily earnings as $80 plus 12% commission on his sales. So I told you we needed two variables. So the first variable we decided x would be the number of days that Mario worked, and y would be his sales. So he has, his earnings are $80 per day. So we have 80 times the number of days that he actually works. Plus we talked about 12% and how when we have a percent, we would change it into a decimal. So 0.12. So 0.12%, and percent we always multiply by the sales. We then looked at this example where Ian owns a small airplane. He pays $50 per hour for flying time and $300 a month for hangar fees at the local airport. If Ian rented the same type of airplane at the local flying club, it would cost him $100 per hour. How many hours will Ian have to fly each month so that the cost of renting will be the same as the cost of flying his own plane? Now, I let you guys kind of try out what you wanted to do, but essentially we started by picking out our variables. So x we said was the number of hours that Ian would fly. And then we let y equal the number of months. So we set up our equations. The first one was the rent. The first one was the own. And it says that he pays, that should be this, $50 per hour for flying time and $300 per month. So $50 times his flying hours, so 50x, plus $300 for each month that he goes. And then we set up our rent. equation, which said that he has to pay $100 per hour for each time he flies. So that would be 100 times X. I then asked you guys to kind of figure out when would the cost of renting be the same as owning the plane. And so what one of you did was decided that you would try different numbers, and you came to the conclusion that maybe X would be 6. We tried a couple of different ways, but in the end, the rent one times 6 plus 300 for 1 month came out to 300 plus 300, which was 600. So that was the own. And then the rent, 100 times 6 was 600. So at 600, they're the same. At 6 hours, it would cost the same. All right, so then we looked at a third example where we had to look at these equations for 2 lines. What are the coordinates of the point of intersection? Our method 1 was graphing with slope and y-intercept, and I reminded you guys that the slope and y-intercept looked like this, mx plus b, where m was our slope and b was our y-intercept. And so what we did was we took our 2 equations and kind of put them into slope and y-intercept, graphed them, and then found our point of intersection. So when we looked at number 1, I have x minus y equals minus 1. So I wanted to change it so it looked like y equals mx plus b. So I moved the y over to be x equals y minus 1. And then I moved that 1 back over to be x plus 1 because the sign changes when you move it. And we got the equation y equals x plus 1. So our slope in this case is 1, and our y-intercept is equal to 1. Because there's not really a value here for the slope, then it's kind of like I told you guys, it's kind of like a ghost. There is a 1, we just don't write it down. Then we looked at the second equation. 2x minus y equals 2. And I had us rearrange that. So we moved the y over equals 2 plus y. And then we moved that 2 over to get y all by itself. So it became 2x minus 2. And so our second equation was y equals 2x minus 2. So in this case, our slope is 2 over 1, our rise over run, and then our y-intercept was minus 2, so from this one. And then I had us attempt to graph it. And so we looked at this. And I had us, so the first one, the slope was at, the y-intercept was at 1, and our slope was 1, which means we're going to go over 1, up 1, over 1, up 1. and we made a nice line like this. And then the second one, our y-intercept was at -2. And our slope was 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. And so we had a line that went like this. And here was our intersection point, which was at 3, 4. So that's how we did it with the slope and y-intercept form. So then I looked at this and we had method 2, which was actually just intercepts, not slope, y-intercept. I just showed you the intercepts and I showed you how to find each of our intercepts. So what we need to do to find the x-intercept, if you want the x-intercept, you set y equal to 0. And if you want the y-intercept, you set x equal to 0. So we did that for each of them. So for the first one, when I did the x-inter, we set y equal to 0. So x minus 0 equals -1. I talked about how we would move the 0 over. X equals -1 minus 0. Anything minus 0 just stays the same. So x equals -1. Then we did our y-intercept. And for our y-intercept, we set x equal to 0. So x, not x, 0 minus y equals -1. Negative y equals -1. And we can drop, I talked about how if we divide by -1, we can drop the negatives. So it just becomes y equals 1. Okay, and then we can graph the line easily by just graphing those 2 points. So this one is at -1 and 0 because x is equal to 0. And in this case, or y was equal to 0. In this case, x is 0, y is 1. So at 0 and 1 is the first one, and -1 and 0 was the other one. Once you have those 2 points, you just connect the dots and make your line. So we could do the other one, 2x minus y. I'm doing the x-intercept here. So I set it equal to 0 equals 2. 2x equals 2. I'll divide both by 2 to get it x equals 1. So 1 and 0 is our point. And then I'll find the y-intercept the same way. I'll set x equal to 0. So 2 times 0 minus y. Anything times 0 is just 0, so that's going to cancel out. I get minus y equals 2. And when I change the negative, I get y equals -2. So in this case, we get 0, -2. So those are our other points. So 0, -2, which is down here, and 1, 0, which is up here. And then we'll just connect those. And you see there is our intersection point, which is the same as the one up above in the previous slide. I said to skip this one, but I will go through it. Brian and Catherine want to get internet access for their home. There are 2 companies in the area. IT Plus charges a flat rate of $25 per month for unlimited use, and Techies Inc. charges $10 a month plus $1 per hour for use. If Brian and Catherine expect to use the internet for approximately 18 hours per month, which plan is the better option? It's not a lot of time. But okay, so IT Plus, if we start off thinking about what is the rate, it is $25 per month for unlimited use. So IT Plus is just going to cost you $25 per month. If we look at Techies, they are $10 a month. So $10 a month plus 1 times $1 times X if we let X equal the number of hours. So if if X is the number of hours, that's X. So 1 times the number of hours. So there's our two equations. If we are to graph these, we can graph it or kind of figure out which is the better option because they're only going to use 18 hours per month. IT is always going to be 25. It doesn't matter. Techies, if we put 18 in there, for X, we'll have $10 plus 1 times 18. It's 10 plus 18, which is $28, which is technically more than IT Plus. But IT Plus is here at 25, and it's always 25. So there's the graph of Techies. Of IT Plus. Techies, I'm going to do it in red, is $10. So it starts out here at $10 and it goes up 1 every hour. So it'll make a line like this. And at 15, this is at 15 hours, is where it would be exactly the same. So you can see that anything after 15 hours, you're going to want to go with IT Plus because it's always just going to be 25. After 15 hours, it's just going to keep going up. So which plan is the better option? I would say IT Plus is the better option. The last example, I showed you how to use Desmos. So if you need a refresher on the Desmos, ask me. I'll show you how to do it. But and I think I probably have a screencast on how to use it as well, which I could totally do if you need it. But I showed you how to use Desmos for that. And then finally, this was the practice questions. So here's the practice questions that you can do for today. And try them. Check back later because I'm going to try and do an answer key just so you guys can kind of check your answers. Okay, bye.